This video is going to cover how you can multiply complex numbers. So before we start multiplying, I just want to revisit the box method. Some of you are familiar with the box method and really like using it. Some of you don't, and that's okay. You don't have to use it. But it's one of the methods that we use to distribute two polynomials to each other when we multiply. And so if I was going to multiply this 3x plus 5 times 4x minus 2, to use the box method, you can write 3x plus 5 on the top, 4x and the minus 2 on the bottom, and then you kind of multiply as if you were finding the area for each of the squares. So this is 4x and 3x, multiply those together, and I get 12x squared. This again is 4x and 5, so 4x times 5 is 20x. Negative 2 and 3x would make negative 6x, and negative 2 and 5 would be negative 10. So then, once we have filled in our box, we rewrite this in standard form and make sure that we simplify anything such as like terms. So starting with the 12x squared would go first. And then I have a minus 6x and a plus 20x. So there's my like terms. I'm going to combine them to get positive 14x. And then we have minus 10. And that's what you'd get if you multiplied these two together. Now, another method that we've used is the distribution. Sometimes it's called rainbows. Sometimes you call it the FOIL method. And it's basically the same as the box, except for we use these little hills and valleys, or whatever you want to call them, the arrows, to guide what we need to multiply next. In both methods, you should get the same answer. So now we're going to apply this to complex numbers. So we have the complex number 3 plus 5i, and we're multiplying it by 4 minus 2i. So as we multiply these, if you set up the box method, the first one we have 4 times 3, which is 12. Then I have 4 times 5i, and that's 20i. We treat i just like we treat x. So in that right there, kind of like how 4x times 5 is 20x, 4 times 5i is 20i. Negative 2i times 3 is negative 6i. And then negative 2i times 5i, well, negative 2 times 5 is negative 10, and I times I is I squared. Now, as we go to simplify these, the first thing I want to do is actually simplify I squared. So remember that we should never have an I to a power that's higher than 1. And specifically when it comes to multiplying, I squared is the most important I to a power that you need to remember. It's the one that we're going to see the most when we multiply. So remember that I squared is equal to negative 1. So real quick to simplify this here, now we have negative 10 times negative 1, which is a positive 10. So as I go to combine like terms here, now I'm going to start with the real numbers first, and we have 2. 12 plus 10 is 22. And now the imaginaries, negative 6i plus 20i is positive 14i. Remember, this is standard form, real plus imaginary, and there is the answer to that. Let's try another one here. So again, I've got a multiplication problem. You can set up the box method, but for this one, I'm going to show you the distribution using the FOIL method, and then you can choose which one you prefer. Using the FOIL method, F stands for first, so I'm going to multiply the firsts together. 8 times negative 5 is negative 40. Then O stands for outsides or outer. 8 times 3i is a positive 24i. Then I stands for inner. So that's I times negative 5, so negative 5i. And then L stands for last. I times 3i is a positive 3i squared. After we FOIL, now we're going to simplify. The first thing I'll simplify is the 3i squared. This becomes 3 times negative 1 since it's 3 times I squared. And so really what we get here is negative 3. Then I can bring everything else down and I'll be ready to combine like terms. I always like to start with the real numbers first, so that way it's right away in standard form. So negative 40 minus 3 is negative 43. And then the imaginaries, 24i minus 5i is a positive 19i. And here's our final answer. All right, we have one more example. In this one, notice that there is not a complex number times a complex number, but this time it's a pure imaginary number times a complex number. So we have just 5i times negative 3 plus 9i. So in this case, it would be helpful to use the distribution method. So 5i times negative 3 is negative 15i. And then 5i times 9i is a positive 40, positive 45i squared. Now let's simplify I squared. So this becomes 45 times negative 1. Remember, I squared equals negative 1. That's why I can keep replacing it by that. And so here I get negative 45. I'll bring down the negative 15i. And now in this one, I don't have to combine any like terms, but then you really need to make sure that you check it's in standard form. Remember, it should always be real first, then imaginary. So the correct answer here would be negative 45 minus 15i. All right, now when we're talking about multiplying complex numbers, one topic that comes up is complex conjugates. So a complex conjugate would be, I'll read this here, two complex numbers that have the same real a values. So they have the same a, and the imaginary terms have the same b value but opposite signs. Those are considered complex conjugates. So right here in this first example, we have a, and then here plus bi. That is a conjugate with a minus bi. So the a value is exactly the same. Bi, it should be the same number for b, but one will be positive and one will be negative. So we're going to match these complex pairs. 5 plus 3i, that would be a complex conjugate with 5 minus 3i, because the 5s are the same. One has a positive 3i and one has the negative 3i. For the next one, negative 2 minus 3i, the complex conjugate would be negative 2 plus 3i. That's right down here. And the last one, even if it's not a complex number, if it's just an imaginary number, you can still find a conjugate. The conjugate of 10i would be negative 10i. Now, why do conjugates come up when we're talking about multiplication? Well, let's actually try to multiply a complex number by its conjugate and see what happens. Starting here with number 1, I have 3 plus 2i. Think for a second, what would the conjugate of 3 plus 2i be? Well, 3 is the real number, so 3 will stay the same. 2i is the imaginary, and that's the part that I need to change signs. So that's going to be 3 minus 2i. These are complex conjugates. Now we want to multiply them together. So I'll put them in parentheses to indicate multiplication. And then I'm going to distribute. So we get 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And 2i times negative 2i is negative 4i squared. All right, I'll simplify the I squared first. Remember, I squared equals -1. This is the one, I know we learned the powers of I, but this is the one that you really want to memorize because it's going to help you the most. I squared is -1. So now -4 times -1 gets me a +4. And I can bring down the rest, 9 minus 6i plus 6i. And now I'm ready to combine like terms. So for the real numbers, I've got 9 plus 4, which is 13. And then the imaginary numbers, -6i plus 6i, ooh, that actually equals 0. So our final answer is 13. Let's try one more. For number 2, I've got -4 minus 5i. First, to find the complex conjugate, -4 is the real number, so that stays -4. Minus 5i is the imaginary. It's going to stay 5i, but now it's going to become positive. We change the sign of the imaginary, putting them in parentheses to indicate multiplication, and we are going to distribute. So -4 times -4 is a +16. -4 times 5i is -20i. -5i times -4 is +20i. And -5i times +5i is a -25i squared. I'm going to start by simplifying I squared. So I get -25 times -1, and that's +25. Bringing everything else down, 16 minus 20i plus 20i. And then I will combine like terms. So we have 16 plus 25. And I get 41. And then -20i plus 20i equals 0. So our final answer is 41. So now the question here says, what do you notice about the products from both 1 and 2? What happened when we multiplied a complex number by its conjugate? Well, if you look at both of them, you might notice that both times our final answer is just a real number. There's no more imaginary piece. So when you multiply a complex number by its complex conjugate, it becomes real.